그럼 이번에는 클라우드 스케일링의 랜디 비아스토표의 강연이 이어지겠습니다. 박수로 환영해 주시길 바랍니다.
Hi everyone. Thanks for having me, and thanks to KT for setting up this conference, and special thanks to Mr. Lee, as Chairman and CEO, Mr. Kim, and Mr. Jung-Sik Suh, who have been incredibly brave, courageous, and thoughtful about embracing cloud computing and really having a very clear vision of what they wanted to accomplish and how they want to help Korea understand what they can do with cloud computing. And I'm a long time member of cloud computing sort of thought leadership, so I was really working in this area since 2006, which is very early on. As some of you may know, Amazon's Elastic Compute Cloud was launched in 2006, so we've really only been in this for 4 years. Right? So that's a relatively short period of time, but a lot of things have happened. And today I really want to share with you, sort of the cloud scaling vision of what cloud computing is, and then how we think that it's changing the game, and then what that means for Korea in particular. So, the thing that I've discovered over the past couple of years is that the way that we do cloud computing is a little bit different from the way that everybody else does. I've seen a number of these presentations, a huge number of these presentations at this point, maybe 100 of them. And every single one starts out by trying to define cloud computing. And every single one tries to say cloud computing is this little thing here, web applications, or this little thing here, self-service, pay-as-you-go, or this little thing here, something as a service. My favorite of all is that it's virtualization. Right? Cloud computing could be all of those things, but I think every time somebody tries to define it, they're looking at cloud computing through a very small window. And all they can see is that little piece that relates to them. And so the question that we have to ask ourselves is cloud computing one of each of these small things? Or is it something bigger? Is it something much larger? Is it something that's more akin to the Industrial Revolution? Is it something that's fundamentally disruptive to the way that we've been doing things in the past? So I think to answer this question, we have to sort of look at where cloud computing came from. There are constant debates about whether cloud is virtualization, whether it's a business model, whether it's a technology, whether it's virtualization, but there is no debate in the United States of America that these are the pioneers of cloud computing. These very large web internet properties are the ones who basically developed it or put it in production first. It's not the enterprise computing vendors. It is not academia. So why? What changed? Google had to run 1 million servers. That's not an easy task. In order to run 1 million servers, you have to do something different. The smallest of the large-scale web operators ran 100,000 plus servers. 100,000 plus. And these are massive, massive, massive scales. In order to get there, you've got to do something different. So when we go back in time, when we look back in time and we say, how have things changed? What really, is there a parallel that we can see before, right? The best one that I can come up with is to look at the Industrial Revolution, which is very similar to the digital revolution that we see today. And that really fundamentally changed the way that business operated, right? We moved into an era where we had steam-powered engines, gas-powered engines, mechanics, tools. The whole landscape changed. We became urbanized. And now that took a very long time to basically play out. And then at the end of that, there was a further revolution. So the Industrial Revolution itself was revolutionized, right? We went from that process that you saw on this previous slide, where we have people manually assembling automotive vehicles, to a model where people design huge robotics factories to actually deliver automobiles. And this is very much what's happening today. We're moving from a model of the individual server or the individual PC to the model of running data center-sized computers. Google is nothing if not the world's largest computer, right? So we're moving from single processors to tens of thousands of processors or CPUs at a time. You can spend $1,000 and you can get a single PC or server for which you can use for several years, or you can spend $100 US and get 10,000 servers for an hour. What can you do differently when you have 10,000 servers for 1 hour for $100? The answer is very, very simple. We can look at Amazon. They've gone in 4 years from having no hosting capability to being the world's largest hosting company in the world, simply on the back of allowing people to purchase thousands of CPUs, thousands of servers for 1 hour for very little money. That's the fundamental disruption. So if we look at that disruption, if we really want to dig into it, I think that we can start by looking at some of these analogs. Electrical power is a great one. This is one way to generate power. Take gas, pour it into this Honda generator, turn it on, you have electricity, you can run tools, you can run some computers, maybe your internet connection. This is one way. Now if you want to take this and you want to turn it into a power plant, you can't simply take 100 Honda generators and put them together and provide electricity to the city of Seoul. That is not doable. However, this is the mentality that we have today when we're thinking about what the problem is. Why don't we just take what we did before and make it bigger and add automation? When the answer is, we need a whole new tool, right? The way that a utility power plant delivers power is it uses completely different tools at a different scale than a Honda generator, right? And that's what Google and Amazon and Yahoo and Microsoft's online services all do. They operate at a fundamentally different scale, using fundamentally different tools, and that's cloud computing. That's how big it is, that's how big the change is, and all of those tools are the things that we need to understand. This is enterprise class, this is utility grade. That equates to enterprise class, utility grade. By the way, this is an actual Google data center, if anybody's curious. So just to kind of bring this together, cloud computing is a new tool. You take cloud computing, all the technology, people's processes, automation, architecture, service models that it wraps. You use that to build cloud data centers, and then in cloud data centers you deliver cloud services. This is what people are doing. This is what everybody's doing. It's what KT is doing. It's what Amazon's doing. It's what Google's doing. So if we go back for a second and we say, well, what was the difference? What was the thing before cloud computing? That's what I call enterprise computing. And it's that manual process. It's those gentlemen on the assembly line putting together a car. This gentleman knows how to put in the radiator. This gentleman knows how to add the tires. This gentleman knows how to add the steering column. It's this process. And it looks very much like your enterprise data center today. You've got a storage server person, you've got a database server person, you've got a systems person, you've got a network person, and they all take care of one part of the picture. And it's all manual, and it's assembled with simple tools. Where cloud computing is large-scale automated robotics, like a robotics factory, and it uses that tool as a base case to actually develop these large-scale cloud data centers. So as we think about that, we can see that this is a huge shift, but it's part of a greater trend. We really started off with mainframe computing in the 60s. Then we moved into the era of enterprise computing, and finally we're moving into the era of cloud computing. Now these are 20-year transitions, right? And they never go completely away. We all have mainframes today, right? But they become the new dominant paradigm for how we do IT, how we create information technology, and how we use information technology. So what's the big deal? How can I really bring this home? How can I explain that this is a game that actually requires that massive scale to play? Well, this is it right here. The Bechtel CIO did an interview with CIO Magazine. He was trying to determine how to make his information technology team and capabilities much better. So when he did his research, he found out that Bechtel, a large large global company was able to manage 100 servers with one administrator. And then he found out Google could manage 10,000. And he was shocked. Right? That's 2 orders of magnitude, 100 times. Right? I mean, that is a huge, huge change. It's the difference between a cost of ownership for labor of $4,500 over 5 years and $45. No amount of labor arbitrage can fix that. You can't go find some new country where the labor is even cheaper to address this issue. Because this is fundamentally about the application of technology. Right? So if you take that labor savings and you extrapolate it and you look at the other things that are in a cloud data center, this is being applied by Google, Amazon, Microsoft, and Yahoo across the board on hardware, software, and power and cooling. Right? Everywhere that they look, they are ruthlessly reducing their costs. And part of this is because it is their core competency. All Google does is build massive data centers to process massive amounts of data. That's their job. It is a fundamental core competency. They will always be better at it than anybody else for whom it is not their core job, their core competency. Right?